So hello and welcome everyone. In this video we are going to discuss a problem of elastic collision from the Pathfinder book. So let's get started with the problem. So here in this problem, this large ball and the small ball are the system, and these are going to fall from a height h which is given in the problem, and they are both inclined at an angle theta, which is also given in the problem. So now this large ball would be coming first towards the ground, and after it collides elastically with the ground, it would rebound, and it would collide with the smaller ball, and this smaller ball will then it will perform a projectile motion, and we have to calculate the range of that projectile motion. So let's get started with the solution. So we know that because that large ball is falling from a height h, in the question we are given that this radius r would be very smaller than h, so we have to ignore this radius of balls. Okay, so before it collides with the ground, it would have some velocity u, and the basics of kinematics, we know that it would be under root 2gh. It would be under root 2gh. Okay, and the smaller ball would be also falling with u first before all collisions. And after collision, after first collision, this larger ball would be rebouncing with a velocity small u, and the smaller ball would be coming down with u after the first collision, and there would be another collision afterwards. And after this collision, it would be let's join the centers of these two balls, and there would be a very impulsive force acting because of this collision, and we have to ignore the gravity and all that stuff. It would perform a projectile, and we have to calculate the range of that projectile in the horizontal direction. So this one is coming with u, this one is going upwards with u, this angle is theta. So we have to calculate first in the direction of direction of joining the centers of both the balls. So this is moving with u cos theta here and u sin theta here, and the smaller one, it is also moving with u cos theta here and u sin theta here. We are going to use a concept of let's say elastic collision. In this concept, we are considering that, let's say there is a huge wall and a smaller ball, elastic ball, and this is coming with u, and this wall is moving with v naught towards that ball. After the collision of this small ball and this massive wall, there would be no effect on the velocity of this massive wall, but this smaller ball, this one, it would have a massive change. It will change its direction, completely change its direction after colliding up to the massive wall. So what would be the velocity of this ball after the collision? This wall would be moving with same v naught velocity. So to calculate it, we know that the coefficient of eccentricity is the velocity of separation after collision, and divided by velocity of approach before collision. So what is the velocity of separation after collision? It would be this v dash minus v naught divided by velocity. What would be the velocity of approach before collision? It would be v naught plus u plus v naught equals to. In this question, the coefficient of eccentricity is 1, so it would be v dash minus v naught equal to u plus v naught, v dash equal to u plus 2v naught. So what we observe, that v dash, the rebound velocity of the smaller ball would be the opposite of its original velocity u. This was the original velocity u, so it's opposite u plus 2 times the velocity of the massive object coming towards it. So this is a very good result which would help us in this problem. So by using that result, we can calculate that this smaller ball is gonna rebound in this direction, which is perpendicular to the line of collision or line of the joining of the center, with its original velocity towards the massive wall. We will consider this as a wall. We have considered this as a massive wall. So with its own velocity towards that massive wall, u cos theta plus 2 times the velocity of the massive wall, and it has the original velocity u sin theta here, which is unaffected because it is perpendicular to the line of collision. So now it is a basic question of projectile motion that this ball has a velocity of u 3u cos theta in this direction and u sin theta in this direction, and we have to calculate its horizontal range. Some might have a question in their mind that this ball is colliding here and it would have a projectile motion like this, and it would also, this range will be also considered, but there is stated in this question that this radius r is very less than h, so we are just ignoring this extra range and we are calculating only this one range. So for this we have to convert it into a simpler problem of projectile. We know that this angle is theta, so this would be 90 minus theta, this would be again theta, this would be again 90 minus theta. So let's make the components accordingly. Here it would be 3u cos square theta. In this direction we are making the components of this velocity vector in perpendicular direction, and it would be 3u cos theta sin theta in this direction, and we are making now this velocity vectors component, so it would be u sin theta dot cos theta in this direction, and it would be u sin square theta in this direction. So long story short, this ball is moving with an upward velocity of 3u cos square theta minus sin square theta, and in the forward direction as 3u cos theta sin 4u cos theta sin theta, 4u cos theta sin theta, which would be 2u sin 2 theta. Sin 2 theta. Okay, let's go. Now we know that the range equals to time of flight into horizontal velocity. This is the formula for range. So now horizontal velocity, we know that this is the horizontal velocity, and to calculate the time of flight we can use this. We know that if a ball is moving with a v velocity towards upwards, its time of flight would be 2 times of v by g. This is a basic formula of kinematics. So we can calculate the range directly. Okay, let's simplify this one in the form of 2 thetas. So what would be the vertical velocity? It would be u, taking u common, 3 cos square theta minus sin square theta. So it would be u cos square theta plus 2 cos square theta plus cos square theta minus sin square theta. So it would be u 2 cos square theta plus cos 2 theta. And what is 2 cos square theta? It is 1, 2 times of 1 plus cos 2 theta plus cos 2 theta. It would be u 1 plus 2 cos 2 theta. Okay, so this is its vertical velocity. So now we know the formula for range. This is the v vertical, 2 times of v vertical upon g, multiplied by V horizontal. So this is basically 2 times of U 1 plus 2 cos 2 theta into V horizontal. That is, what is V horizontal? Here it is, 2U sin 2 theta, 2U sin 2 theta upon G. So this 2 and this 2 becomes 4U square, and here it is 1 plus 2 cos 2 theta, and here it is sin 2 theta by G. Let's take 2 common from here, so it will become 8U square upon G, 1 by 2 plus cos 2 theta, and here it is sin 2 theta. Putting the value of theta as 30 degree, and U square is as 2GH, 8 into 2GH divided by G multiplied by 1 by 2 plus theta is 30 degree, so 2 theta would be 60 degree, and cos 60 is 1 by 2, and sin 60 is root 3 by 2. So it would be 16H. This would be 1, and this would be root 3 by 2. We know that what is H, so the value of H is